Okay, we will wait for some time, like 1 or 2 minutes, and we will start with today's session. So this is a live session. So in this very live session, I will be discussing about recursion, right? So how recursion is actually implemented and how you actually trace recursion. Okay. Now let's proceed with this very session. So we have over here, hopefully my voice is audible and the picture clarity is okay, right? Please do state if you are facing any sort of problem, right? Yes. So tracing recursion. In tracing recursion, what we are hoping is we want to perform recursion. Now recursion is what? Recursion is nothing but doing the very task repeatedly but without using any looping mechanism. Now how that very task can be done? So we have talked about functions, right? Now functions, what are those? Functions are simply modular approach of performing programming. So what we are doing is, in modular approach, we are simply dividing the task into multiple scopes, having a particular modular name, and we call that very modular name to perform certain task, right? Now in case of recursion, what happens is, just think about it. When we call the function, where is this function is kept? The function is actually kept in the main memory. So we have the main memory, and within the main memory we have the main function, we have various functions, whatever is defined, it is kept in the main memory itself. So say suppose this part is the main function, and this part is a function which is called the add function. Now this add function starts from the address 2000 and the main function is at 3000. It might be the case, it doesn't matter. So this main function will be using the add function. So for this very task, what it will do is, it will simply call this function add. When it is calling this function add, what happens is, there is a register. That register is called the program counter. Now that register is responsible for holding the address of the last instruction, right? The next, or rather the next instruction which is to be executed, that is held by the program counter. So previously it was holding some sort of address, say suppose it is 3009. So 3009 was the address, after which at this very stage the add function was called. When it was called, it was previously this, and what was the next instruction that it will be executing? It will be 3010. So it knew that 3010 is the address which is to be executed after the calling of the add function. But when this add function is called, this program counter's control goes back from here to here, or it is changed from here to here, because it was previously executing the instructions that are there in the main function, and suddenly it executes a instruction which is actually a call to another function. So when a call to another function is made, the control goes back to the add function, and the next instruction address, which is 3010, this is not executed for the time being. But think about it, after the execution of the add function, the control will be transferred back over here. So it has to know that after this calling, when this add is being executed, it has to come back and it has to execute the rest of the instruction. So for this very purpose, it has to know that 3010 is the position from where it will start. So this 3010 has to be stored somewhere. That place where the thing is stored is called the stack memory. So it is like this. I will simply give you an example. Say suppose you are studying. studying and doing a particular math problem and you are at math number 5, the question number 5, so you are doing that. Now when you are executing, when you are actually solving the problem for 5, your mother calls you and tells you to fill up the water bottle. So what you do is, you know that you are doing till 5, so you stop there and you go and fill up the water bottle, right? After that you come back and you start doing from 6, because previously you have executed 5 or you have written down or solved 5, right? So but that thing has to be stored somewhere. You have to write it down or you have to mark it to indicate that you have done till 5. Else if you come and you will start doing from the first again, no, it is not possible, right? It is futile. Doing the very same thing again and again, it is futile. So what we do is, whatever problem we are doing, we mark it and we go do some other task and then we come back and do it from that very task, right? So we do it in this very manner. Now another thing, I will be taking the problems after this class, right? So this is not a doubt clearing session, I'm just clearing it out. After the very session gets over, I will be taking your problems. So over here, program counter was executing 3009. Now the next instruction which is to be executed is 3010. But the call to add has changed this program counter's content from 3010 to 2000. Hence the control goes back to add and the add function is executed. This 3010 has to be stored somewhere, which is called the stack memory. So whenever a function is called, main function or any other function, a part of the main memory is reserved for this stack. This stack is actually used for calling. Whichever is called, an instance of that very function is stored in the stack. Again, if another call is made, that function's record is stored into the stack. In this very manner, not just this program counter, various other details are also stored. So stack is a part of main memory where the calling of the functions are kept one after another and it is popped in a last in first out manner. A simple example of a last in first out is like this. We have the Google Chrome, this browser, right? In the browser, what happens is there are various tabs, right? We have various tabs. Whenever we click on a new tab, another new tab opens. We click on a new tab, another new tab opens. And whenever we close it, we go back. So where are we currently? We are currently at the last open tab. That is the last created tab. When we close the tab, we go back to the previous one. When we close it, we go back to the previous one. So last in, first out. The last created is the first one to be closed first. It's not that like that. We can switch obviously, but the flow of the process is in a last in, first out manner. Same thing goes for stack also. Last inserted thing will be the first one to be popped out, right? Now, 1 minute. Now, let's proceed with an example of recursion and see how recursion is actually happening. So, over here, what is happening is, we have this very function and the name of the function is A. Within A, what we are doing is, we have passed on a parameter and that parameter is n. Now, this n is actually any sort of integer. For now we are considering an algorithm, not a program. So we haven't stated any return type over here. We haven't stated any data type over here. So n is integer. For now you consider it as an integer. Now let's see what is happening. If n is greater than 0, printf n minus 1, and we are calling this very same function a with n minus 1, that is the content of n, whatever it was, it is now reduced to 1, right? Now, so it is now reduced to 1. So what happens is, main, and we are calling a of 3. A of 3 and n is equal to, first what happens is, this is the stack memory. Within the stack memory, first the main function is pushed into the stack. the main function is calling a with 3. So a of 3 that is being called. So first an instance of main is pushed into the stack, then a of 3 is pushed into the stack. So now just think about it, how many lines are there in this function? There are like 1, 2, 3. There are 3 lines which are there in this very function. As hopefully my voice is audible, right? Let's check. Yes. So 1, 2, 3. So we have these 3 lines which are to be executed. So the first line is if n greater than 0. So just check once. An instance of main is pushed into the stack and then we are calling a of 3. So a of 3 is also pushed into the stack. So when a of 3 is pushed, the value of n, just think about it. If n is greater than 0, obviously 3 is greater than 0. So it goes into this second line. So it is printing n minus 1. N minus 1 is what? 2. So it is printing 2. Right? So 2 is printed. Fine. Then it is calling a of n minus 1. Right? So a of 2 is called. But which line is left to be executed? Let's consider this closing bracket as another line. This one. Right? So which line is left to be executed? This closing bracket or this closing of scope. So let's consider that fourth line is left to be executed. So just check once. In the main function we have called this and after this there is no line. So we are not mentioning anything for now. But in a of 3, n is equal to 2, that is being printed, and after that the fourth, this is being called, a of 2 is being called. So a of 2 when it is called, the which line it is left to be executed? This line, that is it has to come out. So a of 2 is called. Again we check 2 is greater than 0. Yes. Printf mod t n minus 2, which is n minus 2 is equal to 1. So 1 gets printed. Right? And after this what we do is we specify which line is left to be executed, which is 4. Then again this very a of 2 is actually after printing 1, it calls a of n minus 1, a of n minus 1, which is 2 minus 1, a of 1. Right? And finally it prints this, and the line that is left to be executed is a of which is 4. It is again called, but check once, when a of 0 is called, n is greater than 0, it won't enter the if statement. So it directly comes here and this gets popped out and it returns back to this. Fourth line is left to be executed, which is actually the closing bracket. Then it is popped out. Same for this. Popped out, same for this, popped out, and it returns back to main. Now let's just modify a little bit, right, so that we are able to understand what is actually happening. Let's don't call this over here. Let's state a of n minus 1 here, right? So let's see what happens. So we have the stack. Now within the stack, first the main function, then a of 3. How many lines are left? Just check once. 1. This is the second line, this one, and this is the third line, right? Let's do it. So the first line is if n is greater than equal to 0. 3 is greater than equal to 0. Yes. Then the second line, a of n minus 1, that is a of n is currently 3, a of 2 is called, which is fine. But which line is left to be executed for a of 3's instance? The third line. So this has not yet been executed. In a of 2, when a of 2 is called, 2 is greater than equal to 0, right? A of 1 is called 2 minus 1. And which line is left to be executed? The third line. So it is mentioned or is pushed into the stack for that very instance. Then a of 1, the same thing, a of 0 is called, but which line is left to be executed? The third line, right? So a of 0, it won't enter this, so it will directly come out, and it is popped, it comes over here. A of 1, the third line is left to be executed, which is, it has to print n minus 1. Currently n is 1, so n minus 1 is 0. Then it comes back to here, because after this it has to return back to its previous calling function. A of 2, over here n is 2, so n minus 1, if we print it, it is 1, and it comes over here. And after this, in 3, n is equal to 3, so the third line which is printed, that is n minus 1, 3 minus 1 is 2, so 2 is printed and it comes back over here, right? So this is the way the calling is done in case of recursion, and this is the way the instance of functions are pushed into the stack and the calling is performed. Now this tracing of recursion is either done in a stack based approach or in a tree based approach. So whatever I have shown you over here is a stack based approach. Let's go for a tree based approach and see how it happens. Achha, is there any doubt till now? Hopefully this stack based approach you have understood, right? Let's go for a tree based approach and see how it is done. A of n, if n greater than equal to 0, printf, I am not specifying anything, I am just giving a shortcut for now, n, or rather I don't know if you will be making any mistakes for now, so let's give mod b. Then a of n minus 1, then again printf mod d n, and finally we have this. So we have a function, just look into the function, a of n, if n is greater than 0, printf mod d n. A of n minus 1 is called, right? A of n minus 1 is called, and again we have printf n. So this is the work. So how will you give the output for this very recursive equation or recursive function that we have given? You can do it with the stack based approach. It is completely right way to do it. So you mention step 1, step 2, step 3, or line 1, line 2, line 3, and you do it in a stack based approach, which is okay. But let's formulate this in a tree based approach, which is another way of doing it. So just check it once. We have a of, let's say a of, not n, a of 3 is called. N is equal to 3. So over here a of 3, what are the 3 lines that we have? Printf n, a of n minus 1, and printf n. So 2 printing, 1 calling, right? So we print, what is printed? N. What is called? A of n minus 1, that is a of 2. And what is printed? N. Right? Again, a of 2 will perform the very same 3 lines, 1, 2, 3. Printf n, a of n minus 1, printf n. So it will printf to a of n minus 1, that is 1, and it will printf 2 again. Again a of 1, what it will do? The very same thing, 1, 2, 3. So a of 1 is printf 1, a of 0, printf 1. Now a of 0, when it is called, it cannot enter the if. So just check once which thing is stopping the whole of this. So when you are actually going for a recursive equation or a recursive function, there should be a stopping criteria or a if within it, which is actually performing the calling. This stopping criteria is very important when you are repeatedly calling a function, because we don't have any loops. We are performing the very same thing of addition, subtraction, or traversing through the array, linked list, or any other 2D array or anything with the help of calling a function. So there is no loop, but there should be a stopping criteria which has to be determined. So it will come with practice. It's not just it will come directly. So we have the calling over here. This is how this function is actually called, and it stops over here, right? So let's trace out the output. So what you will be doing is, you will consider that the person is standing over here, and you will trace out the whole of the path. Check, I'm tracing out, right? Yes. So it's like a Christmas tree, right, for this very calling. Now what do we have over here is, whenever you encounter whatever you encounter first, you do it. So I'm just going through this very path, and I've encountered a printf, right? So what do I print? 3. Then I go. Then I encounter a calling of function, which is fine. You don't have to do anything. Then you go here. Then again print it 2. I'm going, calling, printing 1. Then I'm going, calling. Then again printing 1. Then I'm going, then printing 2. Then calling, then printing 3. So this is the output. 3 to 1, 1 2 3, right? So this is the output of this very recursive function that I've given you. If you call from the main with anything, this will be the output you get. If you call, say suppose if you pass 4, so you will give something like this: 4 3 2 1 1 2 3 4. It will be something like this, right? So this is pretty much for this tree based calling. Now let's proceed with some more, and let's see how it is actually done, and you will be able to understand. I know this there might be a shortage of bandwidth. If it is difficult to follow, please you can watch it later, but if you are interested, you can look into it now, right? Because this is very important. Recursion is one of the most important thing that you have to do. Now let's give another this equation, and let's see how it is performed. Say suppose I give a function f of n. If n equal to 0, simply return. Then return means just simply control back. So you can return something, or you can return just simply the address, nothing else. When you simply mention return, it means it's the control is given back to the calling function, right? So if this is the case, you do this. Else you do n minus 1 printf n f of n minus 1. So these are the lines that you're doing. This is line number 1, this is line number 2, line number 3, line number 4. This is a checking, and after that you're performing this. So if I just write this and call this, what happens is, let's check it, what happens. Say suppose there are two questions. First question is, what is the output? So the first question that I am mentioning, what is the output? And the other question is, how many function call is performed? That is number of function call. So the name of the function is f, and within f you are passing n. So from main function, you call this with f of, say, suppose 3, right? This you can do. Let's see what happens. Or rather f of 2. For now, let's make it short because we don't have much space. So f of 2 is performing this. N is equal to 0. 2 is not equal to 0, right? So it won't enter this. It goes here. F of n minus 1. F of n minus 1 is f of 1. Third line is printing. So it is printing n, which is actually 2, and then calling again f of n minus 1. F of n minus 1, n is 2, f of n minus 1. Right? So we have this. Now this function and this function both will perform again. So f of 1, it won't go here. So it will execute 2, 3, 4. Because n is equal to 1, so n is not equal to 0. It won't enter here. It will come here. F of n minus 1 is f of 0. Printf what? Printf 1, f of 0. Again for this one, f of 0, printf 1, f of 0. F of 0 is again called, just think about it, when f of 0 is actually called, n is equal to 0. If n equal to 0, simply return. Return means the control will be transferred back to here. So if f of 0 is even called, or f of 0 is actually over here, so it doesn't matter actually. F of 0 is actually returning back the control to here. It is returning back the control to here. It is not performing or calling any further because this if is stopping this. So we trace out the whole of the process the very same manner. Right? And we will be printing whatever we encounter first. So what do we encounter first? This calling. Calling is fine, nothing to do. Then we go, calling is fine, nothing to do. Then we go, calling is fine, nothing to do. Then we go here, printing. Then again calling. Then printing. Calling, printing. And finally we reach this. So it will print 1 to 1. So if you are given with a code and you are given with a calling, that f of 2, if it is called, what is the output? You have to do it in this very manner. You can do it in a stack based approach also. It's fine. But a tree based approach is more sophisticated for this type of examples where there are multiple callings and this sort of architecture is there for the function. Now it's not just you will be told to give the output always. Sometimes it might be the case you are told to write a program using this recursion also, right? Let me just check if any sort of problem is there or not. So Roshan Singh is asking, sir, can there be a system where, say, at last step of recursion, value of n is equal to 1, then the control is sent to the previous recursion, but for all previous recursion, the value of n remains 1. Sorry, Roshan, I don't get it. Can there be a system where, yeah, obviously you can write the whole of this. It's not just that this very thing is occurring in this very manner. You can control it with the condition. Condition is the most important thing with which you are doing. So let's just formulate a factorial and let's just see how it is done, right? What I want is a factorial of a number, nothing else. Till now I have given you some examples where you are actually giving the output of recursion. Now let's formulate a function which is actually performing this recursion. Let's do it for factorial. So we have, say, suppose void main, and within void main your printf and you are calling mod d what you are calling? You are calling factorial or fact of 5, right? Simple as that. So whatever you are calling this fact, something will be returned here, and what thing will be returned here? It is mentioned, mod of d. Mod of d is nothing but integer. You can take this into a separate variable also, and you can print x, but over here I am doing it directly, so to just reduce the amount of time invested in this very tutorial. So printf mod d fact of 5, right? So we are calling fact of 5. So let's call fact of 5, and the return type of fact will be an integer. So int, you mention the return type fact, and you are passing an integer over here, so int n. Now, as I have said, there are two things. One is the calling, the other is the stopping criteria. So first you have to think, what is the stopping criteria for factorial? Just think, factorial of 0 is 1, factorial of 1 is 1, factorial of 2 is 2 into 1, factorial of 3 is 3 into 2 into 1, and factorial of 0 is 1 obviously. So it is 3 into 2 into 1, which is 6. Like this it progresses. For 4 it is 4 into 3 into 2 into 1. So it is stopping at 1. So if n less than equal to 1, or you can specify this also, if n equal to 1 or n equal to 0, anything. If n is less than equal to 1 or n is equal to 1 or n equal to 0. If this is the case, you simply return an integer which is 1, because factorial of 1 is what? 1, and factorial of 0 is what? 1, right? Else you will return what? You will return the current number, which is n, and you will call this factorial. Say suppose 4. So 4 is actually what? 4 is actually 4 into fact of 3, right? So n is actually what? N into fact of n minus 1. Isn't it so? So this is the recursive equation that we have, which is formulated, and it has to be put here. So n into fact of n minus 1, right? So this is it. Let's do it. Let's see what happens. So fact of 5 is called. So let's do it with a tree based approach. Fact of 5. This fact of 5 goes here. 5 is not equal to 1 or 5 is not equal to 0, right? So it goes into the else part, and what is returned? What it will return? 5 into fact of 4. So this fact of 4 is again called. 4 is not equal to 1, is not equal to 0. So it won't return 1, it will go into else part. 4 into fact of 3. Same way, 3 into fact of 2. 2 into fact of 1. This fact of 1, when it is called, 1, n is equal to 1, n is 1, 1 is equal to 1. So it will return 1. So whatever the calling is, it returns 1, and over here 1 into 2 into 1, which is 2, is returned. So this 2 into 2, 2 into 1 is 2, which returns back and comes over here. 3 into 2 is 6, returns back and comes over here. 6 into 4 is 24, which is returned back and it comes over here, right? Are you getting? And 24 into 5 is 120, which is returned back and it comes over here. So it comes over here, what? 120, and we are printing mod of d, which is an integer, Hence, we have just formulated the recursive equation for a factorial, right? Let's check if any difficulty you are facing or not. Hopefully, you are understanding whatever I am teaching, right? Now, I will give you one example and I will stop for today, right? Don't worry, you can copy it down later on. So this is a problem from GATE 2001, right? GATE 2001. So let's solve this problem. So void ABC char star S if S of 0 equal to /0. This is a problem for string. We will simply return. Return means just control back, nothing to return, no value. A, B, C, S, so this is within this. Okay, this is part of this. S plus 1, A, B, C, S plus 1, printf, mod C, S of 0. And in the main function, ABC 1, 2, 3. This is called. So this is pretty much it. Just see once. In the main function, we are sending 1, 2, 3. 1, 2, 3 is actually ABC of 1, 2, 3, and over here a pointer char star S. So this string is sent over here. String is nothing but an array of characters. So after this very operation, when this is sent over here, S is actually a location over here, and we have something like this. The first location 1, second location 2, the third location 3, and finally we have slash of 0. The address to the first location, let it be 100, then 101, 102, 103. And the first location address 100 is held by over here, right? Just check once what I have formulated. 123 sent over here. The first base address of 1 is held by S because it's a pointer, obviously. If S of 0 equal to slash of 0, we are simply return. So if we are at the end, if S of 0 is this, then we are return. ABC S plus 1. ABC S plus 1. S is what? 100. So 100 plus 1 is 101. 101 is sent. So I will just formulate the tree based approach so that you understand. Okay. So we have ABC with 100. Then ABC 101, ABC 101, printf 1. Then okay, I'll just do this so that it is helpful. ABC 102. So this is the first line, this is the second line, this is the third line. These are the 3 lines that are executed for each of the function. ABC 102, printf 2. Okay. ABC 102, ABC 102, and printf 2. Obviously it's a character, right? ABC 102 is again calling. So we have this. ABC of 102 is calling ABC of 103. How it is done, I will tell you. ABC 103 and printf 3. ABC 103. Okay, there is no space. ABC 103 printf 3. Again same. ABC 103 ABC 103 printf 3. Same again, ABC 103 printf 3. Let's do it. Let's check once. So ABC of 100, ABC of, just check once, this is 1 2 3 1 2 3. First location is 100. So this is 100. ABC of 100 is called, and this 100 goes into S. That's why ABC of 100. 100, the first address 100 goes into S. ABC of 100 is called. ABC of 100, what it is doing 3 tasks. This checking is performed for returning or stopping. These 3 tasks are ABC of S plus 1. S plus 1 is 100 plus 1. 100 plus 1 is 101. 101 is actually, so this 2, 3, this is sent. 2, 2, 3, this. From here, here, here. This is the new array which is sent over here. So ABC of 101. Again in 101, so which is the 0th location then? This is the 0th location, this is the first location, this is the last location. So ABC of 101 is again calling, so S of 0 is 2 actually, so it is not ending. So ABC of 101 is actually ABC, calling ABC of 102 and again ABC of 102 and finally printing S of 0. S of 0 for now is 2 because this is the 0th location, right? From ABC of 102, it is actually this and this. So the new array is this which is sent to here in ABC of 103. So the 0th location is here and here. 0th location is 3 and the last location is /0. So ABC of 103 is called. ABC of 103 will again called ABC of 104. But it doesn't matter because in 103, this is the new array which is whose location is 0, whose base address is 0. So the whole calling is something like this. And the printing, we will simply go in this manner. This is a bit difficult. I am just doing it fast because we don't have time much. So we will be, so don't miss out anything, right? So you will be traversing through whole of this. Right? So just check once. This is how it is done. You do it on your own. It will be better. So ABC. Finally we have a printf over here. So 3 is printed. Then we go. Then we are again going. Then again 3 is printed. Then we are going. 2 is printed, going, 3 is printed, right, 3 is printed, 2 is printed and finally 1 is printed. So 332, 332 and finally 1. This is how actually it is done. I will just revise this again, don't worry. Because many of you might have missed and I am seeing that a lot of people has left already. So I will just repeat this very task of this calling of recursion again. So don't worry. And finally we have this output. What you will be doing is we will give you an assignment. It's not that you have to do it by this very duration. You can submit it by today and please respond to your IMCRP quiz for now, right? Thank you all for coming, right? If you have any doubt, please mention in the comment section and I will be addressing it. So if you have any doubt, please do tell. I don't know if you have understood this or not. So hopefully you have understood a little bit. There was a shortage of space due to which this part I couldn't just formulate it. I need a little bit of more space. So just write the equation and I will do it. Okay, so do you have any query for now? You can mention it, right? Okay. So hopefully you can proceed with your this okay. Shododip Roy, sir, how can we draw the tree? It is confusing. Yes, the tree is a bit confusing approach, but think about it, it's always like this. When you are calling ABC of 123, you are calling with the base address 100 and you are doing 3 tasks. ABC of S plus 1, ABC of S plus 1 and printf S of 0. So currently for this array, S of 0 is this. So we are printing what? S of 0 is this, 1. So you are printing 1 and you are calling 100 plus 1, 100 plus 1. Now when it is 100 plus 1, the new array is 2, 3 to here. So this is the 0th location, this is 1, this is the third. 0, 1, 2. This is the thing. So when you are printing S of ABC of S plus 1 is called, this is 102. ABC of S plus 1 is called, it is 102. And printf S of 0, a new S of 0 is 2 for the 101th instance. So in this way, for every calling, you write 3 things. And finally, you do a breadth first search. This is called actually a breadth first search. So whatever you encounter first, you print. So if you are not encountering a calling function, other than that, if you encounter a printf, whenever you are encountering a printf, you print it. Like that you go on. Right? Hopefully you all understood this. Thank you all for coming. Right? So I will be closing the live for now. And let's proceed to your IMCRP quiz. Okay. Thank you.